Thanks a lot for coming, guys. Hope you got some lunch. My name is Praveen. I'm one of the product managers for vCenter Operations Manager. So today's session is about how you can troubleshoot issues in your environment using VCOps. So what I'm going to do is start off with a quick introduction to the suite, and then hand it over to Sam, who's our architect for VCOps.
Yep, that'll do.
And so Sam's going to do a demo right after that. I'm pretty excited to show you guys an early sort of sneak peek on what our engineers are working on as well. So there's a tech preview section. Just a note on the format of this session is going to be pretty interactive. So feel free to ask questions while we're showing you anything in the demo. There's actually a mic here right next to the projector. So we don't have a stand mic for this section. So you probably just want to come here and sit and ask the question, and the same goes for there's another mic there. So we just want to make sure that your questions are part of the audio recording so other people can benefit after the session as well.
Or if you're shy, just shout it out and we'll repeat it.
We'll repeat it, yeah. Standard disclaimer. Have you guys seen this before? Okay. So quick overview of the VCOps suite. So our goal really is to provide you all the tools you need to run and operate a cloud, which includes not just the operations piece, it also includes the day zero provisioning aspects of it. And once you have the environment up and running, how do you get visibility into cost controls, where your risks are, et cetera. So that's the focus. So today we're talking about the operations piece. Now, if we have to give you access to make you run and operate a cloud, we obviously need visibility to a larger piece of the environment. So to that end, if you look at the VCOps suite, our goal really is to be sort of the best in class for a vSphere environment, but at the same time, because the scope of operations is beyond just the vSphere domain, being able to go and extend out to other pieces of the environment and bring that visibility. So we have what we call as management packs. Essentially, these are, think of them as a data collector and a bunch of content around the collector. And these allow us to sort of extend out beyond the domains of purview and get additional data. So we have what we call as a solutions exchange, where our partners develop management packs that allow you to extend the core product functionality. So we have partners like NetApp, EMC, Brocade, Cisco, et cetera, who have developed management packs that provide domain-specific value. And our goal really is, once the data comes in, provide a common set of operation visibility across these domains. So when we say VCOps, we're really thinking about 5 distinct domains: performance management, availability management, capacity, configuration, and compliance. And so we want to provide the same set of coverage for all these domains with a common user interface and a common set of constructs. And it's important because as you're troubleshooting an issue, you don't want to have different pieces of information at different layers of the stack. So we sort of tend to normalize all that information up into easy to consume analytics, which actually Sam's going to go out and demo. And finally, we have a set of APIs and SDKs that allow you to extend capabilities beyond what we provide and do some bit of automation on that. So today's focus is just going to be about how you can troubleshoot common issues using VCOps and the different approaches. So it's not just about a prescriptive approach. So Sam's going to actually talk about how you handle certain issues and how you should think about them, and what are the capabilities in the product that allow you to pinpoint problems. So with that, I hand it over to Sam.
Thanks, Praveen. So let's, before I start demoing, one of the things I'd like to do is talk about what we need to understand before we start looking at screens. And one of the screens that we have is the workload badge, workload details. And what I like about this details area is that it has a lot of information on it, and it explains a lot. So for CPU, we have this scenario. CPU demand is high. What's next? Look at the details. And the next step, it says CPU demand is greater than usage, and demand is greater than entitlement. So looking at this bar on the bottom, we have the green bar is the demand, what we call demand. The gray bar is usage. And simply the way that we describe it is demand is how much the virtual machine wanted, and usage is how much it got. And generally, the difference between them is contention. When I don't get what I want, it's called contention. All right? So that's at the high level. The pin that you see, the little ball with a stick, is ESX doing entitlement. So in this case, we have a configuration of 2.66 gigahertz, but it's probably overcommitted because I don't see a limit, and I don't see a limit is the flag way over to the left. There's a limit. If the limit was causing the entitlement issue, I would see this limit up in the bar. But in this case, it's got to be population pressure. I've just overcommitted all the CPU, and this VM is asking for more megahertz than the hypervisor can schedule. And then at the bottom is this little blue bar. That's important in our system because we do a lot of behavior analysis. And so the blue bar is the range of motion that we expect the virtual machine, the CPU metric, to be in at this time for this hour. So if you have high demand and it's outside of its blue bar, then you can say that's unexpected high demand, right? So there's a lot of information going on here, and it's really important to understand what we're saying there. Any questions?
The actual limit is on the same thing as the entitlement.
The actual limit is the same thing as the entitlement.
On the side is reserved. The limit is actually blurred by the entitlement mark.
Oh, is it?
Yeah.
Doesn't look like it.
That's what you can tell the same thing because the limit and the entitlement is the exact same 1500 megahertz.
I know when we took the screenshot, it was not supposed to be a limit, but
There's a limit.
okay. So this gentleman has identified, where's Waldo? Yeah. He's identified that there is a little bit of pixel there that says that the limit is underneath that ball. So that could be the case. Okay, so to simulate this,
You can see both.
yeah, and the number is there as well. So whoever took the screenshot did it wrong. Wasn't me. But it was supposed to be a population issue. And if the flag is there, then you know it's a configuration issue. This is a good example of several things cause contention. So if I have a limit, it's configuration, and that's where Praveen was saying we need configuration and compliance to help us understand the root cause of the problem. If it's not a limit, you can have the same situation through reservation shares and entitlement. And if they're both at the very top, then you could have issue with just the configuration. Now there are other things. If you see that what it's not getting is it's not by entitlement and it's not by but they're still not the same, there can be contention caused by other things, and we'll get into that. Okay. So in this case, we have something similar, and I'm using a graph, a different visual on this one. We have something similar. Demand is greater than usage, but demand is less than entitlement. In this particular case, just to cut to the chase, this system is idle. So what happens is ESX is detecting the idle thread, the idle loop of the guest OS, and not scheduling it. And we call this an idle tax. So you can have a situation where your VM is got what it looks like contention, but the demand is less than entitlement, and you got to go look at the why. And the first one I look at is idle. Then I'll go look at some others like co-stop. Let's see what we have here. Is this one co-stop? No. So I'll show co-stop in the live demo. So that one was idle. This next one we have, this is a good example of many of my customers that I've talked to ask me, why is the data different in all three screens in the product, right? And the first answer is because of time resolution. So in this particular case, we got a 5-minute comparison to a 20-second comparison to a 1-hour roll-up. And you can see that the 1 hour is completely smoothing the data. it's not going to have the same value. It should be an average of all that data. And the 20-second is going to be even more exaggerated in its spikiness. So just remember that all computers run when they do work. They don't walk. And the appearance of it walking is because we widen out that time window, and it averages the sample for that whole 20 seconds or 5 minutes or 1 hour. And so when you're doing diagnostics, it's important to use these graphs for what they're intended. The hourly graph might be used for planning. I know that all those spikes aren't going to happen all at the same time, so maybe I can have some complementary workloads and use this hourly to see how many VMs I can put in. If you have a problem and you can't see it through the data in a low resolution chart, you can have something like conflicting workloads, where you put 2 VMs that are part of the same application on the same box, or somehow they got co-located. And what will happen is a request or a transaction will go through the web app, then go to the database app, and then go back to the web app, and then go back out, right? And so when that happens, you'll see an average demand that is low, but a contention that is elevated. And it's hard to explain. And you can only see it if you get high resolution data. So when you get to diagnosing, you want to get lower and lower, higher and higher resolution. Okay. The second is you got to understand what metric we're using for what purpose. So for example, ESX may use the metric consume to, not for capacity planning or for right sizing. It'll use it just to show how much it's allocated plus gotten back through its techniques. So like ballooning or sharing or something, or any of those other, or compression. Any of those techniques that ESX uses will be the granted minus those techniques plus buffers or overhead, and you'll get a different number. And for this UI, it's perfectly adequate to show something like that. But when you're trying to right size a virtual machine, you don't care how much it granted and gotten back. That's a game for the hypervisor. What you want to do is see exactly how much memory or CPU the VM is using. And for that metric, you need something else. We used to use resident set size inside the guest and so forth. That's even coming harder and harder to use, because things like database and Java, they allocate all this memory up front on the heap and manage it. They manage it themselves, right? So what's cool about virtualization is we can slip in between the VM and the hypervisor and actually see how much memory the applications are actually storing data and fetching out of memory locations. And that's called active memory. And so what we've done for VCOps is we've created a metric called memory demand that is based on active memory. The problem with active memory is it doesn't show you things like when there's contention. So you have to inflate the active memory by this % of the time that it wasn't able to access memory. So the first step is to inflate it. The second step is it doesn't account for non-pageable memory, things that are in the guest OS. A kernel can't swap everything out, and it doesn't touch everything all the time. So you have to inflate that by a little bit more. Okay? So once you understand what you're looking at and using the metrics for what their purpose is, then it becomes easier to use the product for debugging things in your environment. So with that, I'm going to go ahead and just kind of kick over to the live area. Okay, so let's refresh this screen.
This is 5.8.
5.8. All right. When you first log into VCOps, this is where you land. And I kind of call this my front page. How's my day going to be? You know, if there's a lot of yellows and reds, I know I'm not going to have a very good day. If it's mostly green, then I can manage it and I don't have to go home and skip work today. So the problem with this is that it's at the world, so it's simply going to show you a population answer. And there's two ways to or multiple ways to do problem investigation. The first one is if you happen to have time, you can go to a screen like this, click on the glowing red things, and drill down and investigate. We'll do that exercise. The right way is probably, hopefully, you have your alerts set up, and you get an alert, and you simply go to the alerts page, you double-click on the alerts page, and it has all the data for you to tell you what's wrong with this system. The third way, which is probably the most popular way, is to wait for a phone call, right? So I just ignore all this, you know, it's cool and all, it's academic, but I'm just going to wait for a phone call. It's much easier to wait for the phone call, and you would use the product slightly different for a phone call. So I'm going to show kind of all three ways of getting to a problem. So we're just going to, the first one, we're just going to assume I have so much time on my hands, I can just double click somewhere. I see this red box that drew my attention. I see the health is some number. It's 23. How did we get 23? Anybody know? No? You guys are all new users to vCops? All right, let's go.
I thought that's why you're here, Sam.
All right, let's go see, let's double click on this and see what we get. So when you double click, where it takes you is to the details page for the health on that widget. And we see a serial box, I call it a serial box, Wheaties, that has a 6-hour time history, and you see the colors that are green, then it goes yellow, and now right now it's red. So something's going wrong. So I see next to the health badge 3 little badges. One is 90, one is 65, one is 0. Those badges are workload, which is the gear, kind of signifies working. Anomalies, which means I'm doing something that was not expected, right? If I have the way that we calculate anomalies is that we take all the metrics that we're managing for a VM, or any object, if you will. That sum count is compared to the ratio of metrics that are violating a threshold. And there's 2 ways to get thresholds. One is a static threshold. So you just set, my threshold is at 60, and that's violating a threshold. Or what we call dynamic thresholds. And dynamic thresholds, which is one of the, I guess, powerful features of vCops, it goes and looks at the history of a metric, looks to see if it has a distinctive pattern. If it has a pattern, it will build a channel of the high and low watermarks for that metric. And then when that metric goes out of that channel, it creates what we call an alarm. Now, the score of 65 is roughly 65% of the metrics are having a problem. I mean, it's not exactly like that because we have a noise level line and so forth. But out of the number of metrics that I'm monitoring, I've got a lot of unexpected movement. And that's what we see. That's why we use the anomalies badge instead of individual thresholds, because when problems happen, they happen in buckets, right? It's like a school of fish. Not one metric will go south. You'll see disk I/O elevate, then you'll see CPU and memory and all kinds of stuff when things go wrong. And so what health is a geometric mean between these 2 numbers. And what that means is it basically means that when they agree, it accelerates. When they disagree, it deflates. So if I had an average of 0 and 100, it'd be 50 between 2 badges. A geometric mean, it's about 20, 22. Okay, so it basically says, I don't think these badges agree. It's high workload, but I expected it, so that's okay. Or if it's low workload and I expect it, that's okay. But if it's the other way around, then we're going to elevate the health, and that's how it goes. So then you look down the page and you say, okay, what is it? It's disk I/O. So I have CPU, memory, disk I/O. Something is going on with this box. It's generating a lot of disk I/O. The workload is very high, and I did not expect it. So I have a score of 65, which is kind of high. I have certainly a score of 90 that's really high. I can click on the details, see that this box has disk I/O that's high and it's not expected. All right? So that's one way to solve this problem, right? It's just kind of drilling down into the system. I went from the front page, one click, down to this page in the details. I clicked again, I compared the badges, I clicked, and I found the problem. Now, let's go to that person who's... So this guy might be complaining. This guy may be generating the problem, and you have somebody else that's impacted by the problem. In that case, you have this guy's peer. Let's say this guy, this virtual machine that is on the same box, he's not doing a lot of disk I/O. But if you look at his numbers here, these are really tiny. That's his latency. His read latency is at 85. His write latency is at 149 milliseconds. Is that high? Yeah, I was hoping you would agree. So more than likely, this guy will be complaining that his VM is slow, right? Because he's being impacted by that other guy who's running something on the same data store. And so you can easily, when he calls, hopefully he'll have enough information, and you just simply, type in the name. It'll go search. You go click on it. It'll take you straight to this page, okay? And then you can say, yep, looks like you have high latency. Wow, that's interesting. Why don't I go look at your storage? Your storage, sure enough, has high latency. So this is the details of the storage. And then if I want to, I can double click on that storage. Maybe I can't double click. We'll just go to the environment because I wanted to show this off anyway. So we have this environment area that once you identify that this VM is suffering, it's the one highlighted, I can go look at its data store, or when I click its data store, or its host. So I can just simply hover over. I see that workload is 54, not bad. This one's not bad. And this one is 57%. But the nice thing I like about this widget is from here, I highlight here, I click on this one, and it automatically kind of picks up everybody who's related to it. It highlights it. It makes it really easy. So that it looks like that job that I was running stopped. So I was running a disk I/O. Yep. My demo, I talked too long.
So the good thing about the details page also is that the way we organize the page is that when you first come to the page, we immediately have the impact right on the top. And also, you will notice this, what does this mean link? So when you click on that what does this mean link, we populate some best practices and troubleshooting knowledge in the page itself. And not only that, we actually provide you recommendations on what you should do when you have this problem. So this is very useful for folks who are not familiar with the product, but want to know more about how these metrics are calculated and what they're doing. And finally, when you have a problem, what are the few things you should do to remediate? And I'll talk about it, some of the new features later in the demo on how we sort of codified that into the product a little bit better.
Yeah, so my benchmark stopped, but you can see this red spike on the data store. It went all the way up to 100% on this guy, and you can see the graphs showing that. So real quickly, I can see that I've got several VMs on one device. It's actually on the same host in this particular case. I got one VM that's being a bad guy, and the others are suffering from it. If it was the other way around, like I didn't have any one big writer, but the latency is high, I have another visual for that. So over in the analysis area, we have heat maps. And what I like to do is, if I have a, wow, it's using a lot. I guess my benchmark is working again. So the heat map is great. Let me go to the world. That's what's wrong. All right, there we go. So the heat map is great to see that that condition of, do I have a villain and victim situation, or do I have just a death by 1,000 cuts? If we were a death by 1,000 cuts, you would not have this one big box. You would have a bunch of boxes. They would be about equal size and proportion, but they would all be colored kind of yellow-red, right? So what's nice about heat maps are they have 3 dimensions. One is the hierarchy. So I see that my data store is this data. And then I have my virtual machines, which is concentric boxes inside. And then the size of the box is the amount of I/O that it's putting off. So if they were roughly balanced, they would be the same size. And then the color is the amount of latency. So it's a really good visual for diagnosing CPU, memory, disk I/O, and doing that noisy neighbor versus death by 1,000 cuts. Now, the right way should be alerts. I kind of save this to last because, you know, it's kind of boring. I go here, I see a problem, I click on it. It says, yes, you have a problem with your host, it's a workload problem, and here's all the data. And so you can see that it's one the difference between this graph and what we're doing in live, what this is nice about, is the alerts can help you with that, hey, Bob, you know, last night at around 2 a.m., there was some kind of problem. And were you looking at it? Were you looking at the screen at the time? What happened? And you, of course, say no. So the alert captures all the data in time when it happened. So all these visuals are not the current state. It's the time that it happened, which was at 7:45 p.m. Okay? That's an example of that. And then you can see the stacked. You see this is, you can hover and see the demand for the CPU. You see which one is causing it. This is, a co-stop problem. So I have a virtual machine that's running a high workload, and it probably is chasing these other guys out to the point where if I had load on those other guys, this one would probably have co-stop because it couldn't schedule it. So let's go talk about those metrics that are important. On any given virtual machine, once you've gotten past just the initial root cause of whether, you know, which resource it is, which VM it's on, it's happening to, and then what host it's on and related data stores, you can come in here. If you're still not satisfied, you can go to all metrics. Now, this area, what I like about the all metrics is there's a lot of detail in here that kind of not says, hey, you have a CPU problem. It actually drills down a little bit further and says, okay, I have a CPU problem, I know that, but I can't explain why I have a CPU problem. Is it just a workload inside? Is there some virtualization techniques getting in the way? And I'll point out my favorite metrics. So I start just down the list. I go look at co-stop. I go look at idle, I/O wait, swap wait, and just ready, if you will. Okay. So if I've seen many scenarios where I come in here and I look at customer's environment, and they give me an ESX top, and they'll say, hey, look, it's got this much CPU ready. And I say, well, okay, let's start with what kind of overcommit ratio are you using? And they'll say, you know, I'm 4 to 1, 5 to 1, something, 10 to 1. I say, okay, what's your mix of single vCPUs and multi-vCPUs? Do you have any large multi-vCPU? And they'll say yes. I say, well, how large? Well, our customers demand the best. you know, we're running Minecraft. I need 8 cores because that thing needs to run really good. And I'm like, you realize Minecraft is single-threaded, right? And they go, oh, I don't care, I need 8 cores. So, I have seen many cases where this situation is fact. They have these 8 vCPU VMs, and they really only need like 2 at the most, or 1. And the way that I go look at that is, I go look at co-stop here, and then I go to the planning side. I say, okay, let's go look at that VM. I go to the planning side, I go run a view called Oversize VMs. This is I want this guy. Average. I'll go look at this report, and I'll see that 8 vCPU. If it says anywhere near 1 to 2, I say, okay, you got a co-stop problem. I'll go, you're just building too big of VMs, and you're putting them all in the same box. And the way that scheduling works is that, you know, a megahertz is not a core. So I have to put cores on cores, vCPUs on physical cores. So when I'm trying to schedule that, I got to wait for all the other cores to evacuate and give me space. And then I can schedule it, but I only may use like, you know, milliseconds of the CPU time. So the problem is you got too many cores, and it's counterintuitive to suggest that you could actually have better performance by removing the cores that are getting in the way, right? And that's one way. Then I've had other customers, I lost my place. Okay. Then I've had other customers actually have like a database on there, and they'll see significant CPU that is caused by I/O weight. Very heavy database. I'll see the contention, and they say, oh, should I add some more CPUs, or is that CPU caused by population pressure, or what have you? I look at it and say, nope, you're just doing a lot of I/O. The hypervisor has got to do some homework for that VM, and it's making you wait. So even though you want to run, it's going to make you wait until that data comes back. And then the bad one is if you see swap weight. If you see swap weight, let's say greater than 0, it's bad. I mean, this is swapping at the hypervisor, and what happens is the VM has to halt. So you want to avoid this, and you want to try to get the swapping done in the guest if you have to. I would again use my planning pages to kind of look at the memory and look at the right sizing of the memory, and then look at my memory metrics and see what's going on. So we can do that. We can look at memory. Are there any questions so far? No? All right.
You can customize the serial box to show a different time?
So the question is, can you customize the time range of the serial box? The answer is no. We do have something in further analysis in the future that I'll let Praveen talk to. I'll make sure he has some time to.
I mean, we do have something called as policies that allow you to control how the analytics behaves for certain groups of your deployment, especially if you want to do production versus test. Essentially, what you're controlling is when the box should turn red at a particular threshold value. So you can do that. You can say, for my test workloads, I don't care about workload. I care about some other things. Or if I want to tune up or tune down my capacity calculation algorithms, I can go into a policy area and say, for these group of objects, I want to tune the thresholds differently. So it doesn't. So basically, what you have to separate out is the collection of the data from the consumption of the data. So the consumption of the data layer, at that point, you can control how you want to consume the data for different audiences, depending on what they care about.
Enterprise version you're showing here, or what do you get?
Am I showing enterprise? Yes, I am showing enterprise. This UI is available at the advanced level. If you have standard, then it kind of removes a lot of these tabs and so forth from the standard version. But enterprise gives you this UI, plus it allows you to. Yeah, the question is it the same virtual appliance? And the answer is yes. It's just a license key change to go from standard to advanced to enterprise. There is something that we call a standalone install. It's a non-virtual appliance. That one does not have capacity. It's simply for those customers that are used to using what used to be the product called Alive. And we've maintained that standard installation, but it's in the future that you'll talk about. It's all merged. So no more separate UIs, no more different features based on how you install it.
I mean, the way to think about it is that what is your scope of management? If you're a vSphere team whose day-to-day responsibility is vSphere only, you're pretty much okay with the lower editions. The higher editions allow you to install management packs, which I talked earlier, that allows you to extend the product to bring in additional domains of visibility like network, storage, operating systems, etc. So that's what you get.
So in the last session, people will ask me about the custom UI. So for this next one demo, I'm going to show you a good use case for the custom UI. And I like to do this for diagnosing. So for diagnosing, what I do is I hit New tab, New Custom UI. I drag first. I know that I'm going to use this for people calling me. So the first widget I'm going to throw out there is a widget that shows all my resources that are being managed. Okay? Then I know I'm going to want a graph. You know, graphs are cool. So I drag this graph, and I'm going to use these together. Maybe I want a heat map. And then let's take a look at root cause. So I now have 3 ways to look at an object. And I probably want a metric picker. I always seem to want that. So we'll put that in here. And I want this metric picker higher. Please? Please? Okay. It's not going to agree with me. All right. So now, I'm missing some real estate here, Praveen, on your. There we go.
Give it a name.
Yeah. Diagnose. Now I've got all these widgets, and they're not configured yet. And I'll kind of arrange them here. And I'll show you something, if I can find the resizer. Anyway, I can't get the mouse to cooperate. So I've got a resource selector, I got a metric, I got a heat root cause, and a metric picker. So what I want to do is I want this widget to drive these widgets. So to do that, I turn on, I click on interactions. And so that first one's called resources. I don't want it driven by anything. The metric, I would like it driven by resources and the metric picker. The heat map, I also want driven by resources. And the root cause, resources. And the metric, resources. Okay. Now what I can do is when somebody calls, I can simply type the name in here and say, I want object XYZ. Let's just pretend it's this first one. Now that I got that object, I can click on it, and you can see all these other widgets go into work. The first thing the metric picker the metric graph does is select, through analytics, the most interesting metrics that it thinks I want to see. So these would be metrics that we classify as KPIs, which are key performance indicators, or metrics that are violating their thresholds, either through anomalies or static, and you can see that it picked one that is violating, and it shows them, okay? So here we see that this guy is showing me on this guy, this VCOps suite, this happens to be the same VM that was being impacted by that disk I/O. And so here you can see that the metrics it selected automatically for me are read latency, write latency. So since the latency was going out of its normal, it automatically picked it. And it helped me do this diagnosing much quicker than if I had to hunt for metrics. Now, if I want additional metrics, I can simply double-click on these guys, and let's say I want commands per second. And why do I want commands per second? I want to make sure this guy's not shooting himself in the foot, right? This was a situation where one VM was doing all the I/O, and this VM was suffering the latency. And then if I want to see how things led up, I can see that here is my root cause ranking. This is the same as the anomalies. These are all the symptoms that are in the system for this object and its related objects. So we have the virtual machine. The first thing that happened is the data store started to do something strange. And the data store, it shows that the read rate started going high on that data store. And it shows on the disk that we have read rates, workload is high for the disk. And then for, these are all similar elements, but storage, and then virtual disk, VMDK, went high, and so forth. So let me explain. I'm zipping through this, but let me explain this chart a little bit. So what we're showing is the symptoms for this resource. So right now I've expanded something called virtual machine, virtual disk. That is the virtual disk of that VM. The blue bars are the timeline. So you see that little kind of sliver, that blue sliver in that blue area? That's the time that that symptom started firing. And if you have a bunch of them, you'll see this cascading effect of, this led to that. It was data store I/O, led to a VMDK issue that led to CPU, memory, and so forth. The squiggle means that it's a dynamic threshold. It's one that we calculated on ourselves. And the red triangle says it was violating above. And then the light bulb says it's not happening anymore. It's not active, or it is active, right?
Question, if you wanted to make that display like that kind of as a dashboard, is there a way to suppress like the top bar in the operations manager bar and stuff so you don't waste screen space on it?
You can do the Chrome trick where it's Alt F11 or F12. What is it? Is it F12 that removes most of that Chrome above?
Well, no, I meant that'll remove that'll suppress that'll force the window to full screen, but you still have the home dashboard, the home menu bar. Is there a way embedded where you can actually kick those?
No, we don't right now. We try to minimize the amount of real estate that we consume up there, but we have heard requests to make a dashboard that's just full screen with no borders and stuff like that.
And will this auto refresh?
Yes, it will. You can auto refresh per widget. I can set each widget to have a refresh. I can even bounce between dashboards. I can say there's a timer that will switch between host memory and diagnose and so forth. There's several options to use for how you want your data shown in a NOC. Like if you want it hands-free, you can refresh it every 5 minutes and rotate through the dashboards. I think in the hands-on lab, they show a good example of that. If you haven't seen it in the back of the room, you'll see VCOps on the dark skin mode, and it's showing several dashboards. It's kind of flipping through those.
The good thing is that you can also protect this by a permission model that is separate from your vSphere hierarchy. So you can have both. So Sam showed a different UI. When you log in, you see that out-of-box experience. Here's everything is custom, so you can create a local user account within the VCOps realm that gives them access to a bunch of dashboards. So that way, you're bringing other admins into the tool and providing them their own domain-specific information that they would like to see. And both of you guys are looking at the same data, which is always helpful.
Okay. We can either show what's coming, or we can take more questions, or we can go do some more root cause of, anybody want to see?
Questions?
One question before you're still on this. So I have the same users who swear that they're going to need 12 CPUs even though they're 32. Is there a good way to demonstrate that you can show that you're just not using it?
Yeah.
Because some of the things they'll say is, well, I'm not using it right now, but at the end of the month it'll spike up for quarterly closes and stuff like this. Does VOps take that into consideration?
It does. That's one important feature of the oversize and undersize. What we do is we have two areas. One is at the lower bound. That's called the oversized area, if you will. But it's the amount of area that the utilization is not occupying. We kind of say you're not using any CPU. Then we have the upper area, which is the stress, okay? And if one single spike goes into the stress area, then we consider it to be right-sized or undersized. So what we do is when we're right-sizing a virtual machine, we go find the low-hanging fruit using the undersize, oversize section. We say, let me just go get the ones that are the most egregiously not using CPU. And out of the 20,000 VMs you have, that maybe, I don't know, maybe it's 19,000. I don't know. So out of those 19,000 VMs, what we do is the analytics takes the last 30 days, every hour of the last 30 days, and it plots it. And then it iterates from the current capacity. It'll go down and keep going down until that spike goes into let's say it's only doing it 1 day a week, or he's using it 1 hour a week. As soon as that spike goes into the stress zone, it stops and it backs off a little bit. It says, okay, the right size for this VM so that I don't cause contention is this amount. And that's what that report is presenting to you. It's not taking an average. It's not taking anything like that. And it's using quite a bit of data. So 30 days gets you your hour of the day cycles. It gets you your day of the week cycles. And then it gets those, once a month kind of cycles as well, or twice a month like paychecks.
And does it run differently?
Okay, I think I heard what you said. It's configurable. So you go as far as you want. You can do all year if you want. So we default to 30 days. The reason is it's kind of like a spoon in the ocean. I don't want to right-size it for something that happened 12 months ago, and I don't want to right-size it for just last week. So there's a sweet spot in there. It may be a quarter for you guys. It may be, I use a month by default, and that seems to work out. What was your question?
So mine was, can you randomize when it takes those snapshots? Because like you said, every hour. But if I'm taking snapshots at the top of the hour, my workload happens at the bottom of the hour?
Yeah, so the question is, I said every hour that we analyze it. And he asked if it could be randomized. And the answer is, you can't randomize it in the product, but workloads typically are randomized. Now, in our next product that we're going to get to, you guys are missing the future. These guys are walking out on the future. It does it at the 5-minute level. So what's cool about that is because we're doing stress analysis and not just peak analysis, you can allow for kind of do analysis by SLA, meaning I don't care if it's in there for 5 minutes, but I care if it's in there for 15 minutes. So you can say 15 minutes of area through the sliding window is 25% of an hour, right? So I can say if I have 25% area filled for any given hour in the last 30 days, then I want to consider that stress. The other cool thing about how we've improved this is that the right sizing in 5.x is only being used for when your VM is oversized. So it can only go this way. In our next release, it goes up. So if you have a stressed VM, we can see that spike, and it's like conservation of work, right? A CPU can go to 100%, and then from that, it's wall clock time. So what we can do is we can estimate a capacity that would take that plateau that's there and shrink it. And so we move the capacity up, we know that it's going to use that load, and that wall clock time will shrink, okay? If there's think time, some application loads have a think time, and what happens is they'll do a little bit of work, think, and wait, and they'll do a little bit of work and think, and so forth. That shows up as a lower peak. It will never hit 100%, right? So you can adjust when you want to capture those and weed those out. Those kinds of apps won't really benefit as much from raising the CPU. So we have that coming.
Cool.
I think he has some screens. Now, this way that we solve problems today is, again, if you're bored, go explore, right? Use the alerts, but the alerts are only going to take you so far right now. Wait for a phone call, all right? I can't eliminate the phone calls. There's nobody who can, I think, except for the telephone guy. But in this next release, you got it?
Yep.
Hit the...
Yep.
Go ahead.
All right, so the first thing you notice here is a new home screen. So Sam showed two different user interfaces, one which was completely out of the box, and the second one fully flexible, customizable. We brought those two experiences together in this new home area now. So you see on the top, there's a whole bunch of dashboards, but what we really want to do is lead with the problems in the environment. So one thing you'll notice here is that based on customer feedback, we removed the scores from the top leading badges, health, risk, efficiency, because we really want to lead with the problem. Like, what is the stuff that is causing red, green, yellow, and then lead with what you can do when you have that problem and any kind of actions there. So to that end, we still have the same concepts, health, risk, efficiency. Health is about immediate issues, risk is about impending problems, and then efficiency about opportunities at the end of the month. But now we have this problem alert area that shows you the key pieces of information. And one important thing to note is that in this version we're working on, we have genericized the models for our analytics to take into account all domains that VCOps can go out and collect data. What this means is that all the capacity analytics, all the performance analytics, and any kind of forecasting we do on capacity is available for all domains that VCOps can go out and collect data on. So storage devices, network devices, operating systems, you can do full capacity planning and forecasting on them. So this is just a blowout of how a alert would look like. The first thing you'll notice here is that we're leading with the problem statement.
You missed a big part.
Okay, go ahead, Sam.
This is your dashboards. We merged the UIs. You have, however you want to start your day is right here. And out of the box, we led with these problems and recommendations. So your first step to diagnosing a problem is logging in, right? Then, go ahead.
Yeah, then if you want to get into the details, within a single click, you can see right up there what the specific problem is, how many objects are impacted, and the set of the actual conditions that led to this problem. And then you can see here, we immediately have a set of recommendations. You can control all of this, by the way. So the way to think about this is that these analytics alerts is what now controls the health model. So you have full flexibility to go out and define them. But when you do, this is the kind of information you would see, where you would see this specific set of symptoms, the impacted objects, the threshold values that got violated, and some key information about that object, when it started, when the alert got updated, etc. And
this is in all of them. So in standard, you get all this stuff that we created out of the box. So for vSphere, we have like 400 symptoms and 150 alerts. And they do what I did on the screen, which is They determine if it's caused by I/O wait or swap wait or co-stop or whatever, and give you a recommended action that was on the top on the previous screen. That recommendation is tailored for those symptoms that you got. We're not going to suggest that you add vCPUs to a VM that won't benefit from it because it's due to population pressure. This one will only be due to the demand is approaching the configure size of the VM. And it's chronic. If it's an instantaneous workload, of course we're going to alert you and we want you to go investigate that, especially if it's not expected.
Are you guys also going to be revving the VCO plugin for VCOPs at the same time? So theoretically, if we have an alarm that the box is, undersized, we can actually trigger a VCO workflow that gets approval that does the
That button does trigger a VCO workflow. You click on it, it goes through a workflow, or you can use Python. You don't have to use VCO, but we've integrated this with VCO.
And also set up vCenter actions like power on, power off, resize VM, etc. Those are the options that you have available. And you can go using our SDK to extend that functionality as well.
Is that stuff tied to your vCenter roles?
Yes.
One point to note about that is that we have merged the two different realms of permission models that we had, the user interfaces together. So now you have object-based permissions and feature-based permissions. So what that means is that you can say, here's an admin role, or here's an operator role, rather. They can only read these dashboards, and based on their privileges to the hierarchy, they can only see these set of objects. So that's the level of control you have now. So this is just a workflow that shows you how easy it is to sort of drag and drop these different conditions to create an alert. The cool thing about this is that you can use the full power of all the analytics badges as inputs. So you can do something like, if 80% of my environment has this high workload and I see a stress condition and I see a 503 service unavailable error message, then do this. So this is a way of sort of combining multiple symptoms, and you can create this hierarchy of different symptoms, and you can say if any of these conditions happen and all of these conditions happen, and then sort of combine that, and you have the full access to all the metrics and properties in vCOps coming from every single domain that we can go out and collect data on. So you can mix and match vSphere, storage information, network information, etc., and come up with this rule set. And finally, you attach some recommendation actions as simple as go call this person, or here's an intranet KB article that you should go look at when you have this issue, and whether you want to stick a VCO workflow or a vCenter action in there as well. So it's pretty flexible interface to easily construct the problems you're looking for, and they're also controlled by policy. What this means is that for certain groups of environments, they don't care about certain types of alerts. So you have full control now to select who gets what and what thresholds do they get the information on as well.
Is it DCAC aware as well? So theoretically, a VM goes into alarm, and it's suggesting resizing the VM, then it then can actually identify the owner within DCAC. So we can theoretically send the owner an approval that your box is undersized and you do enlarge the memory. Please approve.
Yeah, we have the VCAC team is building a management pack for VCOps so that you can manage not only VCAC itself, because the health of it is important when you're doing cloud operations, but also it can tag the VMs that we have in our environment that they're being managed by VCAC.
So we'll have awareness of business groups, et cetera, within VCAC once they have that management pack available.
It's coming.
It's coming.
Yeah, is the answer.
Yep.
So you can do grouping on any property, and all it takes is somebody to put a property on the object, and then you can manage it that way.
Any rough idea on when this new version will be out?
Later this, we currently have a beta going on right now, so you can contact your sales guys to get on the beta to see whatever we are showing out here. Didn't you see the disclaimer I showed you earlier? Okay, so very quickly, we have improved the ability to sort of dissect how we come up with these capacity numbers. So we have a granular breakdown of those numbers so you know where we are getting this data from. In addition, sometimes the out-of-box views only do so much. If you want to do additional level of analysis, what we have here on the right-hand side is what we call as the further analysis area. So here's a quick access to different things, what we call as views. Think of views as a simple set of rows and columns of data that we can transform into a visual, like a pie chart, trend chart, etc. So you can come up with your own views to say, I want to look at inventory information side by side, forecasting information side by side, storage information. You can construct all of that and hang it off here. So the next person who comes in here, they have easy access to that. This is how a view creation would look like. So you would drag and drop a bunch of metrics. You select the type of object that you're monitoring, and say, hey, I want to see a trend chart. Oh, by the way, I want to set a specific time frame for this data to render. And I can also, within the same view, select the ability to forecast this metric as well. So I'm not only looking at data for a particular time period, I'm also seeing how things are trending, almost like in a stacked bar chart kind of manner. So it's a very, very powerful feature. It unlocks the full capabilities of vCops to take any data and transform it into visual. And this becomes sort of the building block for our reports. So what this means is that all these views that you see here, just like a construction kit, you can just drag and drop these different views into a user interface and say, all of these 5 views is now my monthly report that I want to put on a schedule.
Yeah, so the person who asked about the serial box, this is where I was alluding to. I mean, you can, if you want to have, you can see the names that we created. What was it, Praveen?
Yep.
Okay, so we've named them certain things. One is for forecast trend, is more of a planning, so it'll have more data, more time in it. And if you're doing diagnosis, I labeled the diagnosis ones that are only about the last 24 hours that don't have a forecast. The issue is once you get so many metrics on the screen, it just gets too busy. So we've kind of taken a balance and created a set of views for certain use cases.
And beyond the core vCops product, vCops deals with structured data, but sometimes you might have unstructured data in logs. And we know sometimes the last mile to root cause is in the logs, right? So what we're trying to do is make it easier for you guys to get this information all in the same place. So we come up with this new bundle that you can upgrade from a vSOM edition that brings both vCops and log insight capabilities together. And we're furthering the integrations between these two products. So if you start your journey in vCops, you land in the right log files, or if you start your journey in log insight, you land on the right object for further analysis as well. So we're making a lot of improvements to bring the unstructured and structured data aspects of it together. So with that, thanks a lot for your time, and thanks, Sam, for the demo, and fill out the surveys. Thanks.
You got it.